My name is Brent Johnson. I own Redline Performance and Machine, and obviously build Redline racing engines. So Casey got a hold of me and wanted to know if we could put together some kind of real generalized information on builds, things to look for, the differences in different style builds, things like that. So we've been kind of back and forth emailing each other, putting together these slides. There's 9 total slides in there, and I've got some bullet points on it that I want to talk about. I want to try real hard not to go over my time. So I'll try to get through the slides as quick as I can, and then at the end, all the questions in the world that we got, let's have them up until we run out of time. Does that work for everybody? Okay. Obviously, when it comes time to build an engine, the block is going to be the foundation of everything. I absolutely hate to see a customer come to me and they have a very, very big idea of what they want to build, and then we put it all together with a block that's only worth about 50 cents. You built this enormous, beautiful house on the beach, and it's just going to wash away. So our choices on blocks, especially the OEM stuff, I want to start there. We've all heard, the old iron's better. The old iron's better. High nickel contents, this, that, and the other. So the reality is, the 60s and 70s era blocks are definitely a denser and stronger material. There was some better material out there. They were seasoned, as they like to call it. The downside of those blocks is back then the technology as far as machining that material wasn't very good. So you can scour the salvage yards and find yourself that golden 010 block. But if you look down the cam tunnel on it, the core shift on it is horrible. So now we've got a block that has really, really good material, but one side of the block's considerably thicker than the other. Do we really want to start with that? Probably not. So the machining back then just wasn't that great. Now as we jump into the 80s and the 90s era, 80s right-hand dipstick, 2-piece rear main seal blocks were absolutely horrible. That time frame, materials were very, very scarce. We were going through this weird economical switch. There wasn't a lot of money out there. Manufacturing was much, much less. So the cast iron quality of those blocks is not very good at all. The technology for machining that poor material still wasn't really up to standard yet. So those blocks primarily will break much, much easier. They're very, very brittle. Now as we keep going into the 90s, things started to change a little bit. So we jump into the 8080 Vortex style blocks, the 638s, throttle body stuff, single piece rear main seal. Well, if you take one of those blocks, the material of the cast iron is not as thick and strong. However, the machining process is by far better. If you take an 880 block and set it right next to an 010 cast iron block, you can visually see how much better the core shift in the block is. You can visually see how much more consistent the block is. The machining is just that much better because technology grew. Now, of course, as that technology grew, the manufacturers realized, we're getting so good at building these and machining them, we don't need to make them as thick or as strong. So that's the spin-off of the blocks, okay? The LS stuff, everybody's kind of jumping on that. That is actually an absolutely fantastic package. The LS engines are really, really good. Their cast iron quality is about the same as what we're dealing with the Vortex style stuff, okay? Obviously, their weakness is the brittleness of the cylinders. So it's 6 of one, half a dozen of another. Aftermarket stuff. Aftermarket world is huge with blocks right now. Not with just domestic sides, but there's a lot of China stuff that's coming over. And the reality is the China stuff's actually pretty good. As much as I hate to say that, it is true. There's some manufacturing going on that they are 100% mimicking a Dart SHP block and priority main oiling. The material seems to be very, very good. The machining quality seems to be very, very good. I found a dealer that was located far out west, a very big warehouse that I deal with, and The rep that I typically talk to had mentioned to me that they had gotten a very large order of these Chinese blocks in. Would I be interested? So I said, you know what, Tom, here's what we're going to do. Send me to them. I don't know that I'm going to use them, but send me to them. I want to see. If I buy just one, it might be easy enough for the guy to walk out in the warehouse and say, that one looks to be the best. So I figured if he sends me two, at least now I had two to compare. And the reality is it's actually pretty good stuff. Dart, of course, and World are the two biggest ones as far as block strength. They are absolutely thicker in the deck. They are absolutely thicker in the cylinder bores. They are just stronger all around. The block themselves is physically heavier. An average Dart block is right around 220 pounds. That is a lot for a bare block. Okay? The one-piece versus a two-piece rear main seal. I've had that question a lot with my guys. Really, in the block itself, there's no big difference. But there is one small difference when it comes to a two-piece rear main design versus a single. And that is the strength of your flex plate. And I stress hardcore on that flex plate because time and time again, you're beating the front pump out of your transmission. Well, there's a reason for that. So to contain your torque converter and hold it, it has to be seated against the crankshaft. The flex plate's the only thing that does that for you. That's why it's called a flex plate. It's just a big spring. So every time you back up and you hit, the only thing that's holding that torque converter from slamming into the front pump on the transmission is that flex plate. The one-piece or single-piece design crankshafts, their bolt flange is considerably smaller. If any of you guys have ran both designs before, then you'll notice that. Being that flange diameter is smaller, then that flex plate is slightly weaker than the older two-piece design. But other than that, in the blocks, there's not really anything. Okay. All right. Does size really matter? Everybody wants to build strokers, and everybody says, I want the biggest and baddest, and when they show up, this thing's just going to tear everybody in half. There is actually some thought process to the size of your engines. And the big thing is it comes down to the weight and the size of your build. Okay? If you're going to go build yourself a 9,000 pound car, and then you decide you're going to run 302 cubic inches, you can put all the gear to it in the world that you want, but the engine's going to labor. It is going to struggle to move that much weight. You guys don't have race cars, but you do kind of have a drag car. You need to have that 10-foot shot because that's about all you get most commonly. So you need to move the maximum amount of weight, which is your car, the fastest you can move it in 10 feet to put on as much damage to that guy as possible. So I always try to tell my folks that the size of the engine is going to be determined on what you build. My very first question with any new customer is, okay, what kind of shows do you normally run? And what kind of car do you normally build? Are we talking a 4,000 pound car, or are we talking that 9,000 pound car? Because that's going to make a difference as far as what direction we want to go. Obviously, the more cubic inch that we put in that car, the easier it's going to be on the engine as far as labor and stress, but it's also going to be able to move that much weight in a short distance, okay? As far as machining costs, of course there is. Anytime we're going to go bigger on cubic inch, especially stroking an engine, then there's machining costs. There's a lot that has to be done to the block for the rods to swing through. There's a lot for the rods themselves need work in order for the camshaft to fit. I think I covered the car weight. Okay, yeah, let's just go to the next slide. All right, keeping it all together. I get this a lot too. Steel crankshafts, cast crankshafts. For the most part in the Derby world, you guys do turn RPM. That's absolutely true. But you also only turn RPM in a very short burst. Okay? Even a drag car that's turning an 8-second quarter mile, they turn a lot of RPM for 8 seconds. You guys too can turn a lot of RPM for, let's say, 5 to 8 seconds, most commonly. All right. So materials of our rotating assembly, we got steel and we got cast crankshafts. And then we have this voodoo stuff called nodular iron. which is still cast. Okay? Steel crankshafts are obviously extremely strong, but they're also elastic. Steel can flex, and it can bend, and it can take that hard shot without breaking. Now, true enough, they will break at some point, but they have elasticity in them. Cast iron does not. Cast iron is a very, very hard but brittle material, very similar to a file. Okay? That cast iron crankshaft can break before it will ever bend. So in the event that you get that unlucky shot and you're nosed up hardcore and there's your damper sticking out just plain as day, you can't see it because you're in the car and you're nosed up. And you go and put a hit on that guy and that damper becomes your front bumper to make solid contact. That cast iron crankshaft is going to break in half. It is absolutely going to break in half. The steel crank may flex and bend a little bit and not break, but it's also going to take on damage. The difference between the two is you hurt the crankshaft with the steel. When you broke the cast crankshaft, it took everything else with it. So that's something to consider. Okay. Impact forces on your rotating assembly. Thrust bearings are big. Every time you move forward and put on a hit, the car stops, but the crankshaft tries to keep going. The only thing that holds that crankshaft in the block is the thrust bearing. Now you're going to back up and take on a hit. Car stops, crankshaft tries to keep going. So the thrust bearing in your engine gets beat and beat and beat. So a lot of times when I get engines back, one of the very first things I want to look at is the end play of that crankshaft. And that's going to tell me how much damage the crankshaft took. Okay. Forged pistons versus other alloys. So basically we've got forged and we've got cast aluminum, and then we have hypereutectic. Forged materials, you're going to deal with 2618s or 4032. 4032 has very similar characteristics to hypereutectic, so we'll just kind of call those the same. A forged piston is extremely strong, but it grows and grows and grows when it takes on heat. There is not a lot of silicon in them at all, so the clearances for that piston need to be extremely large if you're running on gas and you plan on getting hot. Now, fortunately, I was really happy to listen in on Jason's. With alcohol, it's a little different because that alcohol is helping to cool the head of that piston. If we're on gas, that forged piston is going to grow a lot. And as it grows, it'll finally run itself out of room and start dragging on the cylinder wall, which is creating even more heat, and it's just a snowball effect until that piston decides, I'm done, I can't do this anymore. So now we look at the 4032 material and hypereutectic. They have a lot of silicon content in them, which completely controls, well, let me not say that, really helps control expansion. A hypereutectic piston, if you were to put it in the oven and warm that baby up, throw a mic on it, take it out of there and put it in the freezer and cool it all the way down, the expansion and contraction rate of that piston is very, very minimal. Very, very minimal. So when it comes to heat, it's not so much of a concern of the growth of the skirt of that piston. The downside of those materials, both 4032 and hypereutectic, is they are also very, very brittle. Very, very brittle. If you get debris inside a combustion chamber with a forged piston, it will beat that piston to death, but it won't break it unless it punches a hole through. If you have a hypereutectic or a 4032 material, those pistons are very brittle and can shatter like glass. We run into a very serious detonation problem. We get a piece of debris that gets into the combustion chamber somehow. Our air cleaner got knocked off 5 minutes ago and we're out there running hard and something comes down through the carburetor and you're wide open. It makes its way to the combustion chamber. It crashes into that hypereutectic piston and it will literally explode that piston like glass. So that's something to think about too. All right, bearings, clearances, and oil. I absolutely have to agree with Mr. Koch. Oil is huge. Oil is super, super, super big for you guys. All right, that SuperTech Walmart stuff is not the oil that you need to even come near. Anything like that. We don't want to do anything with that type of oil. The oil is absolutely the lifeblood of your engine. A quality oil name brand is the direction I always push my guys. Okay? Synthetic-based oils are fantastic. Does anybody actually know the difference between synthetic and conventional oil? The myth has always been that synthetic-based oil is man-made and standard oil is crude oil. Well, they're actually both start out crude oil. So there's molecules that make up the oil. In standard crude, the molecules are multiple different sizes. So we got big ones and little ones and even smaller ones and then medium-sized ones. So when they flow to fill those gaps and those clearances, the big ones can't fit into the really small areas, but the small ones can. With synthetic, man does go in and change that. They go in and find the smallest ones and pull them all out and put them in one jug. Now that's a synthetic-based oil. It has basically been screened down to get the good stuff. Okay? Our clearances are going to come into play whenever we decide what weight or body of oil we're going to use. And that's something that I tell everybody, talk to your engine builder. That particular person knows what clearances they want to run based on what oil they want you to run. Obviously, that oil is not just a lubricator, but it's also a shock absorber. There's that very, very thin layer between the crankshaft journals and that bearing. And the only thing that keeps that bearing from making contact with that crankshaft is that thin layer of oil. So it becomes a shock absorber. Anytime that bearing makes contact with the crankshaft, it's like taking a piece of steel and a ball-peen hammer. You hit that piece of steel in the middle enough times, that flat piece of steel just starts to bend. Your bearings do the exact same thing. And our oil is the only thing that can protect that. Temperatures and bearing babbitt. Depending on the type of material that your bearings are made out of, anywhere from 350 degrees to 480 degrees, that babbitt will melt like solder. It will literally melt itself right off of the bearing and puddle up in the bottom of the oil pan. And the next time you bring that engine back to me or your other engine builder and they pop the oil pan off, it looks like somebody just took a big roll of solder, melted it, and dropped it in there. And that's all due to the oil temperature. So bearing material is very, very important. And again, clearances and the bearing material, that's something that you need to talk to your engine builder about. Change your oil every single run. Every single run. That oil is a lubricator, it's a shock absorber, and it's a cleaner. And it's a fantastic diagnostic tool. You've invested a lot of money into your engines. You're going out there, you're running. You're in a dirty environment. Your air cleaners don't seal that good. You're taking on heat. You're beating it. That oil is going to protect it. Change your oil every single run. Check that oil. Look at it. Put it in a clear container so you can see it. Don't just dump it into the same old dirty jug that was in the corner of the garage that I've changed oil for years with. Look at your oil. It's going to tell you things. Okay? All right, let's go on to the next one. Timing. This is something that you guys should be checking every single run. Every single run. All right? The tuning by ear philosophy is a really, really good way to shatter a hypereutectic piston or to run yourself into detonation. Create a lot of heat, lose horsepower. I know for a long time that there was always a theory with timing that if we back that timing down and make it lazy, the engine will be easier to start and it'll run cooler. Well, I don't know where those theories came from, but lazy timing will also create heat. And that's not what we want. So the timing by ear was all about, well, when the car seems like it smooths out as I turn it, then I'm going to make it at that point where it runs the best. That's kind of true. But if you don't know where that timing curve is, then you don't know how you're controlling that flame travel to fire it, then you're going to run yourselves into problems. So find out what kind of timing curve your engine builder has put into your distributor. How much mechanical advance do I have? Do I have any? Is it 10 degrees? Is it 20 degrees? Where do I set my base timing? Where should my timing ramp up? How much full-on advanced timing should I have? All in. At what RPM? These are things that you need to ask. Ask those questions. And then check it every single run. If you check it every single run, you can use it as a diagnostic tool. Okay? If your timing's starting to fall off, and you know that distributor didn't turn, then something inside the engine's starting to fail. We've either got a cam gear that's starting to get chewed off, the distributor gear is starting to get chewed off, maybe our elastometer ring on the damper, it took a good shot, and now that rubber ring that's in there, it's about ready to take that entire cast iron elastometer ring and just chuck it right through the radiator. So you can check that with your timing. Cam bearing wear. If you got it super hot and those cam bearings are melting down like solder, now the camshaft has a whole lot of play in it, the timing chain has a whole lot of play in it, and your engine timing as far as ignition is going to change. So that timing is huge. You need to check it every run. Fuel system. I 100% agree. Filter, 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 filter. Keep it clean, super clean. That fuel system is so incredibly important to you guys. It is incredibly important. Make sure your fuel lines are clean. Anytime you cut that rubber hose, or even just remove the hose and push it back over a barb fitting, exactly like he said, you are pushing those little fine pieces of rubber hose right inside of that fitting, and trust me, they will find their way to the needle and seat at exactly the moment you don't want it to happen. When you're out there and you're just about to win. We're down to 2 cars and I've got this guy, and that little piece of rubber that you didn't even realize you shoved in there finds its way to the needle and seat, shuts you down, and it will not restart. That's the worst feeling in the world. So keep everything clean. Keep those air bleeds cleaned out every single run. Keep your carburetor outside clean. If it looks filthy dirty on the outside, trust me, it's also dirty on the inside. Keep it clean. All right, let's move on. Your ignition system. Cap rotor, wires, plugs, and coil. This chart Casey found online, I strongly recommend you guys find anything like this that's going to show you diagnostics of a spark plug, because that spark plug is definitely going to tell you what's going on inside that combustion chamber. Whether we're too fat on fuel, too lean on fuel, do I got an oiling problem, do I got a mechanical problem? You can read those spark plugs to kind of tell what's going on inside your engine before it fails. All right. Quality wires. Please don't run out to Napa and just tell them, hey, I need a set of spark plug wires for a 75 Chevy pickup. Those will work. They won't work. They will run. But that graphite style wire is very, very high resistance. The outside insulation on those style wires is pretty flimsy. And eventually you're going to run into all kind of misfire problems. Get your hands on a quality, good spiral wound wire that's low resistance, has good insulation characteristics, and that'll help your spark plug diagnosis quite a bit as well. Okay? Non-resistor spark plugs is what I've always recommended. Don't just run right out and grab yourself a set of AC Delcos for a small block Chevy or a small block Ford or whatever it is you run. Get a good quality non-resistor spark plug. We want the spark to jump the gap. That's the point. We don't want any kind of resistance to keep it from doing that. So again, find a good brand name. NGK, Autolite, whatever your engine builder's particular lovable brand is, but just make sure they're a non-resistor design. Read your spark plugs after the show. You guys are building your cars, you're pulling it in and out of the garage, you're riding around out in the field, long before you ever get to a show. So if you were to try to check your spark plugs right there as a diagnostic tool to see where we're at on fuel, it's not going to tell you anything. After you make that run, when it's actually been out there in battle, that's when your spark plugs are going to tell you what's going on inside of there. Because that's when you got it super hot. That's when I ran into this weird miss, whatever the case may be. At that point, you need to read your spark plugs. Okay? Misfires. Misfires are an absolute engine killer for a couple different reasons, but diagnosing them is not that difficult sometimes. Obviously, I'm sure some of you have seen this, I'm hoping, in the pits, but everybody's got headers on their car. There's a tube to each exhaust port. If you have got a dead cylinder or a misfire, find the coolest tube. Chances are that's the cylinder that's having the problem, okay? Start going through it mechanically. Does it look like everything mechanically is okay, or when I took the spark plug out of that hole, is there oil everywhere? Then break it down. Is it an ignition problem? Is my spark plug okay? Is my wire okay? Now look at the cap. When it comes to the coil and the rotor, that's not going to be a single cylinder misfire. Those components are involved with every other cylinder. So you can just pinpoint it down to one cylinder with the wire and the spark plug. If your distributor cap gets cracked, don't repair it with JB Weld. Go get a new distributor cap. Don't seal it up with some RTV silicone and think that'll be fine. It won't. Go get a new distributor cap. Okay. Cooling system. Single pass and double pass radiators. Double pass radiators are actually worth it. They're slightly more expensive. Hose routing is a little weird on some of the cars, but they are actually worth it. Fan choices. Airflow through that radiator is very, very important to keep it cool. Shrouding is a big thing. I have clients that I hand them their engine, they take them home, they put them in their car, their build is done, they call me, I'm ready to go, come tune it for me, whatever. I show up, they've got a brand new double pass radiator in their car. They've got this nice 6-blade flexible fan on there in case it takes a shot. And then there's absolutely nothing between that fan and the radiator for 18 inches. The fan's not doing anything for you. It's doing absolutely nothing. You have to put together some kind of a shroud and make that fan pull the air through it. A lot of guys are using these politician signs, whatever that stuff is. I know a couple of my guys that have done some really smart things with shrouding that I never would have thought of. They go get a Rubbermaid big garbage can. They're rubbery and flexible. And then they cut it to the length they want and the size of their fan, and then they run it to the radiator. So it's flexible. It can take a shot without destroying the radiator or the fan. So that works pretty well. Hot spots and evacs. I really, really like to get rid of hot spots in the engine. Now, obviously, hot spots and evacs only work when you still have water. Once you lose water, the whole thing's hot. But on a typical small block Chevy, the center exhaust ports are side by side, so therefore they're going to be the hottest area of your engine. I'm sure everybody in here has blown a head gasket on a small block Chevy out there derbying at some point. When that head gasket lets go and you tear it apart, directly between the center two cylinders, 3, 5, 4, and 6, is where your head gasket let go. That's because that is the absolute hottest area of that cylinder head. So I like to evac that water out of there. Let's not allow a hot spot to get there. If we evac that water, it does help cool because we have fresh coolant going to that location, but it's only good as long as you have water. Okay. Pulley size. We want to try to run, or I highly recommend running 1-to-1 on your pulleys. And no restrictors. So, years ago I contacted Stewart Water Systems. They're very, very big in racing. They're very, very big in cooling. They probably build the best water pumps that I've ever seen. And I talked to one of their engineers and talked to him for a long, long time about pulley sizing, about fans, about restrictors, coolant flow, and he taught me a lot about pulley sizing. We want that fan spinning with the water pump the same RPM as the crankshaft. 1-to-1. We don't want to overdrive it, we don't want to underdrive it, unless we want to build heat. A restrictor is designed to slow the coolant flow down to build heat. Not to keep the water in the radiator longer to help it cool longer, because just as long as it's in the radiator, it's in the block warming up. So if we slow it down, Yes, it's going to be in the radiator longer to have more cooling effect, but it's also in the block longer to have more heat effect. So you didn't win anything. Okay? We already covered the shrouding. Is there anything else I'm missing? Last slide. Your success is a team effort. Choose your team wisely. Choose your engine builder wisely. You're not out there all by yourself. Pick all of these guys that are out there that have all of that knowledge and talk to them and talk to them and talk to them and ask them as many questions as you can. Make them a part of your team. Because it's a team effort that wins shows. It really is. Okay, you guys got any questions? None?
Easy crowd.
That's good. That's
No,
a
yeah, you killed it.
All right, that's it, guys. Thanks.